Nowadays, passengers think they have a prior claim to the tracks of the railway. And this is true for the daytime, when passenger trains mostly do have it their own way. We take it for granted that trains were invented for passengers. But when they began, railways were meant to carry goods.
Temple Road to Pilot Fox. Come down the yard, please.
Message received.
Push that road down about 20 wagons.
Okay, mate.
That's a second cut, Bert. It's A5, joint line. Range Road number 10, you said, Bill? Thank you.
We're inclined to imagine that the freight railway originated in early Victorian times. But the beginnings are put much further back than that by a leading expert on railways, Professor of History at Leicester University, Professor Jack Simmons.
There have been railways in this country for over 300 years. The first railways originated simply as a device for moving coal and other minerals from the pits and from the quarries to navigable water or to roads. The essential thing about the railway was its track. It was not a device for moving passengers, and it was not in the first place anything that made use of mechanical traction. Now you can see examples of all these primitive railways up and down the country still working today. Very often, like this railway we're looking at now, which is in an ironstone workings near Wellingborough, a narrow gauge line, still of the original kind.
The laying of iron tracks meant an immediate increase in the output of raw materials. For thousands of years, men in the quarries using their bare hands had known that there was plenty more where that came from. Always the problem had been to find swifter means of getting the raw material away. Even where the only available motive force was manpower, the material was moved away so much faster when iron rails had been laid down. Long before the invention of the steam locomotive, the idea of parallel iron rails spurred inventors to new ingenuities. In the earliest days, gravity was often used to speed the freight. The full wagons hauling up the empty. In these old devices, the modern historian sees beyond the quaint and the picturesque. He sees basic principles which obtain to this day.
The continuous chain of tubs is one of the simplest of all means of haulage, and also it's one of the oldest. But if it's one of the oldest, it's also one of the most up-to-date. Because if you think about it, in principle, it's exactly the same as the train, which is just coming into use on British railways now, namely a set of wagons permanently coupled together, moving continuously and always between two fixed points.
But it's only recently that these basic principles were rediscovered. In early times, the railways, with wagons running on their own private roads, were thought to be the ultimate form of transport, whether for long journeys or short. And so, right from the time when iron tracks first went beyond the mines and quarries out into the countryside, the only thought was railways all the way. Even after the invention of steam traction, many engineers looking forward to the spread of railways remain convinced that they had already found the ideal locomotive. To them, the horse was the perfect self-contained traction unit, cheap to run, versatile, and when aided by iron tracks, extremely powerful. Canals, not roads, were at that time the railway's biggest rival. With the brilliant engineering of the time, canals could, lock by lock, be made to go over the highest hills. But to lay iron tracks across the hills and take the goods overland in wagons from canal to canal proved cheaper, more efficient. So, from being adjuncts of the quarries and mines, the railways became an adjunct of the canals, a very important step, as a geography lecturer from Matlock, Derbyshire, points out to his students, Richard Jennings.
It's appropriate we should begin our study of this freight and mineral railway here at Cromford, because this railway was built as a link between the Cromford Canal here on our right and another canal at Whaley Bridge, 33 miles away. This railway was opened to traffic in 1830, and it served to connect the industrial areas of Derbyshire and Nottinghamshire with the growing industrial area of Lancashire. Now, this railway involved some considerable engineering feats because it crosses the high central part of Derbyshire. And the first of these considerable engineering problems we can see on our left, and it is the inclined plane leading up to sheep pasture. The gradient on that incline is 1 in 9. Don't imagine an incline like this has ever been worked by locomotives. It's far too steep. It is in fact worked by an endless steel cable and a stationary engine at the summit.
Hauled up the incline by stationary steam engine, the wagons continued their way towards the other canal, by horse. It was some years after steam locomotives were invented that they were run on these tracks. Steam trains were a very important development, of course. But taking the longer view, they were no more than an episode in the history of the freight railway. Much more important was the engineering of the tracks. Quarries and mines are found in hilly parts, and perhaps that is why our railway engineers were the first in the world to tame such a difficult landscape.
As geographers, we are not interested in the railway operation as such. What we are interested in is the relationship between the railway and the landscape. Now, this section of line we're passing along now gives us an interesting example of this. This is the steepest incline worked by any locomotive in the British Isles. The gradient on the section we're just coming to is 1 in 14. As you can see, the engine is making extremely heavy work of hauling us up this incline. Now, apart from the relationship between the railway line and the physical landscape, we're also interested in the way in which the railway has led to development of industry. Now, this area we are passing through is really an industrial area based upon local raw materials. The limestone quarries, with their output going to the iron and steel industry for blast furnace work, and to the sugar beet industry. We've also can see beside the line a silica brickworks using local silica sand quarried from the local area. We have a plant producing magnesium metal using local dolomite, a form of limestone. Over 100,000 tons of limestone is carried by this railway every year. So we can see that this railway, which was built over 130 years ago, although it has seen a large number of changes in the conditions in this area, is still serving the purpose for which it was built, carrying freight across this central area of upland Derbyshire.
All over the country, it was by now feasible to grab millions of tons of raw material out of the ground. The railways were able to take it away to new factories and new markets. The bigger the output, the bigger the railways had to be to cope with it. The pits and quarries, the industries, the towns and the railways agreed in one thing: the need to haul a vaster and vaster tonnage of raw material out of the ground, iron, limestone, coal, in millions of tons. The more powerful the railways became in carting the raw materials away, the more millions of tons of earth had to be shifted from one place to another. The landscape was transformed. More than a century ago, the railways were the cause of the greatest change of all time in Britain's geography. Valleys and lakes appeared where hills had been. Man-made hills grew above the valleys. In many parts of the country, it became literally true to say that the railways were older than the hills. Naturally, voices were raised in protest. You enterprised a railroad through the valley. You blasted its rocks away, heaped thousands of tons of shale into its lovely stream. The valley is gone, and the gods with it. Whether or not we see eye to eye with John Ruskin, there's no doubt that without the railways, the Industrial Revolution could never have been on such a colossal scale. The 1840s saw the railway tracks extending for hundreds of miles away from the canals and far beyond the mines and quarries. The next step was to join railway with railway so that the whole map could be crisscrossed with tracks. The main railheads in the main towns were important, but equally important were the small stations in the heart of the countryside, which became railway junctions.
Ambergate's only quite a small place, no importance in itself, and yet it became one of the key points on the whole system of the Midland Railway. It began just as a wayside station on the North Midland line from Derby, coming across that embankment there over to Leeds on the left-hand side. And that line was opened in 1840 and built by George Stephenson. Now, Stephenson had a particular interest in this line from 2 points of view, partly because it was one of his greatest works, and partly because he bought himself, with the aid of some Liverpool merchants, he bought himself lime works down in the valley, and he proceeded to work those in close collaboration with his coal works, which he had acquired up at Clay Cross near Chesterfield. Then in 1849, Ambergate became a junction with the opening of the line that was intended to go to Manchester. It didn't get to Manchester in 1849. It didn't get there, in fact, until 1867. And that was because another company, the London and North Western, was extremely anxious to prevent the Midland from getting to Manchester. At last, the obstacles were overcome and the line was opened. And at that point, in 1867, Ambergate became a junction of first-class importance. It became the point at which all the traffic converged, the cutlery and the coal and the lime from Sheffield and from Yorkshire on the one hand, and the cottons and the manufactured goods of Manchester, more lime from the northwest on the other. The two lines joined here and took all this great freight traffic southwards to Derby and to London, and so for distribution across the whole country.
By the 1870s, the railways had fanned out across the country, taking raw materials and manufactured goods great distances to where they were most needed, in the large towns where labor was plentiful and demand was high. In turn, the growth of the freight loads encouraged the towns to expand their industries and multiply their populations. It seemed that the ideal had been reached. A countrywide transport system of private ways laid with iron tracks which could carry anything to anywhere. It was at this time that the railways set the pattern of the Britain we know today. With the bricks from Accrington or Bedford, the slate from Wales, to make streets of houses north, south, east and west, Britain assumed the standardized look it still has. Until almost everyone in the land was in earshot of a goods train. The railways expanded with the economy, becoming the most powerful and the most closely knit transport system the world had ever known. But at the same time, it was building up vast problems for itself. Oddly, it could not get away from the early days of the horse. Still, the wagons were of the weight and size that a horse could haul. As the traffic increased, so did the number of wagons, small, light units, which had to be uncoupled and sorted into trains in sidings. For 100 years, until our own day, the wagons themselves remained no bigger or heavier than a horse could cope with. But the larger the siding, the more inadequate horses began to appear. To replace them, there was a constant search for new techniques. Since 1830, the railways had been obliged by law to carry what they were offered. They were regarded as common carriers. It didn't matter how small the consignment or how remote the destination, a wagon had to be allotted. By a process devouring time and money, each wagon had to go through a succession of couplings and uncouplings before it could reach the end of its journey. The steam loco was a wasteful and ponderous instrument for pushing wagons in ones and twos, but it could shunt to and fro, day in, day out, getting the wagons into their right roads. Strangely enough, it was only about 50 years ago that gravity came to be used again as a motive force. The wagons, pushed over the hump by the loco, ran by themselves down the long slope to make up trains for the different destinations. An obvious next step was remote control. The flow of wagons was continuous, and with push-button control, dozens of trains could be made up at a steady pace.
I have a wagon, G-fan, number 2 road, which is now proceeding towards the automated retarder, where the magic eye will give me the description of its rollability and its weight. It then proceeds towards the secondary retarder, which is operated by me on 4 pressures. Pressure applied at the moment with a description of medium runner, medium weight, is pressure number 2, which I have now taken off. The wagons are now rolling steadily towards G2.
Today I received an order from the GKN Tremorva Works Cardiff for 50 high-fit wagons to meet a shipment order from Avonmouth Docks. I am now going to question the computer to see how many of these wagons I still have to supply to meet the order. I have questioned the computer and I have 20 empty wagons available in my main traffic yard at Cardiff. I will now see how many I have available at Radda Junction, and I have a further 15 available at Radda. I will now move these wagons into the Tremorva Works to meet this order.
But only recently has it been realized that the whole business of breaking up and reforming trains is a century-old legacy, largely irrelevant to our contemporary economy. So the new aim is to get rid of marshalling yards altogether, and on the way to that ideal, to centralize the marshalling in huge yards at main centers, doing away with all the smaller yards which belong to a past era.
The railways of this country are, as far as freight's concerned, at one of the most critical stages in their development, and I think one of the most exciting. For they're engaged in turning themselves into a transport instrument of a new kind, suited to new conditions. The mechanization of road transport has made it quite unnecessary for them to fulfill their old function of being common carriers for all kinds of freight in consignments large and small to all destinations, the things that went by the old-fashioned goods train. Instead, they are freeing themselves to concentrate on the job they can really do best. That's the rapid conveyance of heavy freight in big consignments between large centres of population. No other form of transport can touch the railways at that. But if they're adapting themselves to a new world, it's fascinating to see how they're really returning to the principles on which they began. They're now concentrating on carrying what they're designed to carry. And they're doing it with trains of vehicles that remain permanently coupled together, fitted with continuous brakes, which makes it possible to drive them fast and to know at the same time that the train can be slowed down safely in a very short distance.
The design of the modern freight train is new, but the design of the railways themselves was fixed from the beginning by the geography of the country. To cope with the varieties of curve and gradient, the modern freight loco, hauling ever-increasing loads, has, at the same time, to function with extreme delicacy and precision.
I'm approaching Chellaston Junction, where the line that I'm going to travel on is around a very sharp curve. To make matters difficult, there's a dip in the line, a steep gradient in, a steep gradient out. I've 900 tons behind me, and there's a speed restriction of 20 miles an hour around the whole of the curve. I've got to watch speed and safety of the train through this abnormal dip in the line. I'm going down the first gradient into the dip, taking care not to exceed 20 miles an hour. I'm almost in the dip. I'm increasing power to keep the train stretched out. The line rises pretty sharply now. I'm increasing power, careful to keep it at the speed at 20 miles an hour. I'm experiencing wheel slip. I have an indicator light that tells me wheel slip's taking place. I'm correcting it. I'm going to ease power, I'm easing power, back to normal, the road level's out, I'm back to normal running, everything's okay.
The modern freight train, carrying its great loads of coal or oil or ironstone or cars or manufactured goods, is really fundamentally a very simple instrument. The same kind of instrument as that the railways began with before the first locomotive was ever thought of.
As it has always done, the pattern of the freight railway reflects the pattern of British industry as a whole. The newest mines and the newest industrial plants are centralized in enormous units, aiming always at larger output. And as in the earliest days, the greater the output, the faster it has to be got away. So the newest designs of freight train have come about for the oldest reasons. With increasing production, you must have up-to-date methods of getting the goods away, as the men who first laid down the iron tracks discovered centuries ago.